Now we are going to look at another interesting pattern mining method. It's mining frequent patterns by exploring vertical data format. This method is called ECLAT, or Equivalent Class Transformation method. The general philosophy looks like this. Okay. In original transaction database is horizontal data format in the sense you got every row you get transaction IDs and a set of items in this item set entry. Then you can transform this horizontal data format into vertical data format like this. For every item A, you will see which transaction IDs associated with this item A. That means A bought in which transactions. What's the benefit of this? The first thing is you transform the item set into TID list. The total size is approximately the same if every entry or every ID, they have the similar number of bytes. But the way to compute this will be different. With this TID list, for example, if you say, what is TID list of E? You get 10, 20, and 30. What is TID list of A? You get 10 and 20. Then how to derive AE? You just intersect them together. You can see you intersect this set with this set, intersect two TID lists. You derive the TID list of these AE, this item set. If this one contains sufficient number of transactions, that means it's frequent, like 2, then AE will be frequent. If this one is infrequent, then you don't need AE to go further. That's a similar thing as a priori principle. Then the properties of TID list basically say, if this two TID list is equivalent, that means they have the same set of transactions. If this one is a subset of the other one, that simply says the transaction containing X must always containing Y because this one is this one's subset. So you probably can see if we try to derive frequent patterns based on this vertical intersection, we just need to see the size of these transaction list. But there's one interesting method called diff set to accelerate the mining. The reason is when you get a very large number of transactions, each item may be associated with a very long TID list. Then their intersection, like this E and the CE, their intersection could be small, but their difference could be small. So you look at the intersection is large, the difference could be small. For example, you intersect this two. The intersection is 10 and 20, but the difference is only 1. So you only keep this. You don't have to keep TCE. That may save a lot of space. Okay, this is the general idea. Using diff set, you can further improve its efficiency.